All good online? Recording again?
Yep.
All right, great. So now we're going to start up with our first sort of brand new content unit, looking at biomolecules. So remember I said that in this class we're really going to build things from small to large. And so we're not going to start at atoms, but we are going to start at molecules. And we're going to focus on the 4 most important biomolecules that really serve as fuel and building materials to make cells function the way that they are. There we go. So here's our roadmap, okay, like I always said we would have. And so the very first thing we're going to do is go through some basic vocabulary that's going to help you on how some of these things are termed, and then a few really important processes that we're going to use when we're making and breaking these molecules up. And then we're going to focus, as I mentioned, on 4 really important biomolecules, many of which are going to feel familiar: carbs, right? Lipids or fats, proteins, and nucleic acids. Remember, nucleic acids are the major components that make DNA already. Okay, so I'm going to make lots of jokes over the course of this unit because even though these seem like really small things, they're going to continuously trickle in over the course of the rest of the semester. Right? And I'm going to make lots of jokes about proteins, which are extraordinarily variable in their functionality. So they're going to be our favorite biomolecule. So they're going to do a lot of poking in and out over the course of the rest of the semester, rearing their little faces in with their functions later on. Now, when we go to talk about these, what I really want you to focus on is what do they do and how can I tell them apart from each other, right? So I'm going to make an effort of focusing on these things with you guys, and we're going to actually do our first participation activity. So those activities that we're going to build together throughout the course of the unit. And when we do that, they're going to have 2 goals, which I've got in this orange box off to your right. And so the first goal is to look at what is even the point of this, right? Why is she saying this is one of the 4 most important biomolecules for a cell? And the second is, well, I'll give you several features to look at with this compound. What I want you to say is, if she were to put like 5 different molecules in front of me, which is the feature that I would use to be able to say, that's it, okay, that's the carb, okay? So we really want to narrow down and sort of help ourselves and say, how can I use these pieces of information to tell all of these things apart from each other? And that's really what we're going to focus on. Okay, but first and foremost, our vocab. All right, so term 1, monomer. Okay, and you'll see me probably use this most when I'm talking about our carbohydrates. So you'll see me use the term monosaccharide, literally mono sugar. Okay, but the prefix mono just literally means 1. Right, mono e mono, one-on-one. So if we focus on my example down here, which is an example of a, quote, simple sugar, which just literally means a sugar with 1 ring or 1 chain. I feel like I'm whistling. Okay, so glucose is a simple sugar, and we're going to spend some time looking at all the bits on the sides that we actually care about. We're not going to look at everything. This isn't chemistry. Okay? But for now, we're just going to focus on the core structure. Okay, 1 ring to rule them all. That's it. That's my take-home story right now. Okay, 1 simple ring structure. Okay, so this is a monomer, a monosaccharide. This is how we count. So that's a 1. It has a 1 base structure. That's also done. literally what we're going to do here at the beginning. We're going to count. As you're going to find, biologists be lazy at counting. Not so bad? Easy peasy, lemon squeezy. Okay. So we learned to count to 1. So now we have polymer, okay, or polysaccharides, right? A polysugar. Poly just means many. Okay, and this is where we get lazy. So this can be a disaccharide. Think like di or bi, as in 2. Okay, so if we looked at on the example on the left-hand side, which is all like pretty and colorful, I have 1 ring, which I did a poor job drawing on, and 2 rings. These are not as frequent, probably the least common of them all. Okay, so a disaccharide, so I can count to 2. Then I stop counting because I'm lazy. So I don't have tri and quarts and quads and la la las. You know, you can save that bit for chemistry, I don't care. Okay, after that, it's just not 2. Okay, so if I look at my starch over here, how many rings does my starch have?
3.
How many rings does my starch have?
Yeah.
Poly. So more than 2, right? So this is a polymer. There, we all learned to count to many today. And polysaccharides are very common. Okay, they're the most complex, and these often are both fuel and building blocks, right? So starch, we both know, is like what potatoes are made out of. That's a starch. These tend to be thicker and bigger than like the sugars you find in a candy bar. And we'll talk a bit about that too. Okay, so 1, 2, many. Kindergarten would have been so much easier. Okay, that feel pretty good? Okay, so let's up our game a little bit. So, sugars and compounds don't just magically exist as 1, 2s, and many's. Okay, they get made and broken. And so the last thing we need to talk about is making and breaking our compounds. So, if I have a compound that I need to break, okay, so it is quite large, okay, it's some kind of a poly. In this case, I have a di, right? Got 2 rings. And I want to break that up into 2 monos. Okay, I'm going to use hydrolysis. So literally, hydro, taking water, and I'm going to lyse or break. Lyse means to break or burst. Okay. The other way I remember this is hydrolysis is 1 word, and my starting product here is 1 big starting product. Okay, so let's walk through how this looks like. So I've got a couple here. Jane and Carl. Okay, you know Jane and Carl are a couple because they hold in hands. Okay, they're always holding hands on this oxygen, right? It looks like a little handhold, a little fisty handhold. Into it, right? Okay, so Jane and Carl are like a really bad sitcom couple, very toxic relationship. They need to break up. Okay. So the way we're going to break them up is, as our name implies, we need to add water. So remember, water is H2O. Good. Okay. First thing I need to do is break up Jane and Carl. Okay. So what I'm going to do is erase my circle here so this doesn't get too messy. Okay. Break their handhold. Okay. So now Jane has this like sad open hand, and Carl's got like a bloody stump, I guess. Poor Carl. It's always harder for one person in a breakup than it is the other, right? Okay. We can't leave them like this. Okay, so we have to do something to repair the long-term damage. Okay. And that's where our water comes in. Okay. So for Jane, she's got an open hand, so we just have to fill her open hand in. So we're going to take this H, we're going to give it to Jane. Okay, poor Carl, he's got himself a little bloody stump. Bloody stump's a bigger problem, right? So we gotta fill in his little bloody stump. So he needs a hand and a fill-in. So we're going to give him the hand and the fill-in. We're going to give that to Carl. Okay, so when we look over here, here's Jane, here's Carl. Okay, they both have free hands, living their independent lives. Okay, Jane has her original hand, and we've added that hydrogen on there. Okay, Carl, now we filled in his bloody stump with that OH. Okay, so now they have complete body parts. This is key, right? No one should leave a relationship with missing pieces. Okay, and they're independent, living their best lives. Okay, so the key that we're looking for is we need to start with a handhold. Okay, and then we're just going to fill in the missing pieces with the extra hydrogens and the oxygen. We're going to fill that bloody stump in with that oxygen, right? Everybody needs a hand. Oh, Jane and Carl. Okay, everybody follow what I did there? Okay, so this is the exercise sheet that's posted. Okay, I recommend that you play with it. This is going to take you through hydrolysis, and we're going to practice going the other direction as well. It's going to let you practice that with Jane and Carl, and I make them a throuple, I think, but I can't remember who the other person in their relationship is. So it's going to let you do a lot of practice with doing hydrolysis and the other way, which is dehydration synthesis. Like I said, I'm never going to collect it, but it's really good practice. You'll feel really good. And if you have questions on it, the TAs will go through them in the study sessions as well. And we can do screen shares in MS Teams as well. So you can feel really confident. Because while I'm never going to make you do it on a homework, you will get questions about, is this hydrolysis or dehydration synthesis on exam. So you want to make sure that you feel comfortable and confident about what's going on. Okay, with me so far? Any questions about Jane and Carl's breakup? Okay, let's flip the script. Let's go the other way. We okay online? So, like I said, Jane and Carl have a very toxic relationship. Okay, it's a very 90s sitcom when writers thought that this was okay. So Jane and Carl tried it apart, and they just keep drifting back together, right? It's late at night, they keep texting, okay? They really don't have a good support system. So here's Jane and Carl. So if you have smaller compounds and you're going to make a bigger compound, you do what's called dehydration synthesis. Okay, so think dehydrate, we're going to lose water. Okay, we're going to pull that water back out. Synthesis, right, to synthesize means to make. The other way I remember this is dehydration synthesis is 2 words. Okay, and the compound we're starting with, you're going to start with 2 compounds. Okay, so Jane and Carl are 2 different people, okay, and they want to become a single couple again. Okay, so our goal here is to pull out water. We're going to dehydrate, right? So we need to make water again. Okay, and our goal is to make that handhold. Okay, so as I look at Jane and Carl, okay, here's the hand I'm going to hold on. Okay, so Carl's got to lose an H. Okay, and Jane, I guess we'll give her the bloody stump this time. Okay, she needs to give up her hand and an H. So there we go, H, 2, O. Okay, so that water is what's being released. There we have lost water, we've dehydrated, and now we've got one hand. Jane's got a bloody stump, right? We can't leave anybody with a bloody stump. So at this point, there's only one thing to do. Jane's bloody stump is going to migrate towards Carl's hand. This got weird. Like I said, it's a very toxic relationship. Okay, but in the end, here we have Jane. Here we have Carl. Okay, and here we have that all familiar handhold. Okay, 1 oxygen that they're both holding on to. Nice little fist. They'll be loving and living their best lives for like a week. So they get dramatically divorced in Unit 5. Very committed to Jane and Carl. Okay, any questions about dehydration synthesis? Does this feel good? Does it make sense going both ways? And that's really key. And again, your exercise will take you both directions. You'll get to make them a big couple, break them up, and you'll go both ways and get a lot of practice with it. So if this isn't feeling good, I highly recommend opening it up and taking a peek-see. Okay. You good online? Everybody quiet. Maybe you don't feel the same commitment to Jane and Carl as I do. Okay, so we're going to start just barely looking at carbohydrates today, aka the introduction slide. But remember, as we're going through this, you've got 2 goals, right? Really pay attention to what is the point in each of these molecules. In this case, why do we have carbs? Why would a cell consume a carb, take in a carb? Okay, and in the end, okay, how would I tell a carb apart from all of the other biomolecules? These are the things we want to focus on. Okay, I will let you know, like we'll pause as a whole class and say, you know, take out a sheet of paper or bring up a Microsoft Word document to start the participation activity. But that doesn't mean in your notes you shouldn't also be focusing on these things. Okay, this will be our last slide of the day. Okay, and it's a nice familiar one. Carbs are exactly what you think they are. Okay, food most commonly. Okay, all sugars are carbs in some form or another. Okay, a donut is basically carbs in its purest form. The glazing on your donut is sugar, right? The bread on the donut is sugar. It's glorious. Carbohydrate, everything. Okay, we talked about starches also being carbs. Okay, those are more complex. So the complex carbs can also be building materials. A lot of plant materials are also carbs, like cellulose. Okay, so we're going to go ahead and stop there. You can stop recording me. Woo!